This is either a review, a refresher, or new information for you on simplifying radicals. Radicals are numbers that appear with the radical symbol. The radical symbol looks like a division sign with a little upside down check mark next to it. So this part is referred to as the radical. The part underneath, the number underneath, is the radicand. This is just some math vocabulary for you. And sometimes if you're not finding the square root, if all you see is this with a number underneath it, then it's understood that you're finding the square root. But you also could see a number up here, which means that you would be finding the cube root, or what number multiplied by itself 3 times would give you this right here. And that number is referred to as the index. If you don't see a number there, again, it's understood that you're looking for the square root. So one of the important parts of simplifying radicals is remembering what your perfect squares are. In other words, the number that results when you multiply a number by itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. I think last year I asked you to memorize these because they come in kind of handy to just recognize that these are what we call perfect square numbers, just like we want you to be able to identify odd numbers and even numbers, and so on. So this would go on and on and on, but for our purposes today, probably this list is going to suffice. So simplifying radicals is when you try to find within the radicand if there are any perfect squares that are a factor. So let's go ahead and look at one that's fairly simple. Let's look at 18, square root of 18. So what I do is I look back over at my list of perfect squares, or mentally I do this in my head, and I say, where would 18 fall? Well, it would fall right here in between 16 and 25. So I'm going to look at the numbers that are less than that little squiggly line and ask myself, are any of these factors of 18? And I'm going to ignore 1 because 1 really doesn't help me. So I can see that 9 is a factor of 18, 16 is not, 4 is not. So I'm going to rewrite this as the product of 2 numbers. So I'm going to, and I prefer to write the perfect square number first. So I can split 18 up into the square root of 18 up into the square root of 9 times the square root of 2. That's a perfectly acceptable step in algebra. Now I can take the square root of 9 out from under the radical sign, and I can say, well, that just, the equivalent representation is just 3. So I'm going to say 3 times the square root of 2. And I'm going to look at now the number that is under the radical symbol, and I'm going to say, is there a perfect square that is a product, that is one of the factors of 2? And there is not, because 2 is prime. So my answer here is simply 3 times the square root of 2. And to check myself when I'm doing these, if you mentally take the number that is outside of the radical symbol and you square it, in other words, 3 times 3 is 9, and then multiply it by 2, do you get the number, the radicand, that is under the radical symbol? And yes, you do. So let's try another one. Let's try 24. The square root of 24, this is not a perfect square. It would fall again right here. 24 would be less than 25. So I'm going to look at my numbers that are less than 25 and ask myself, are any of these numbers a factor of 24? Well, yes, 4 is. So I'm going to write that perfect square under the radical symbol first. And I know that it's 6 times 4 gives me 24. Square root of 4 is 2. So now I have 2 times the square root of 6. Now I ask myself, with 6, where would 6 be? Well, 6 would be about right here. Is 4 a factor of 6? It is not. So this is the simplest form that I can get 24 into. So my answer for this would be 2 times the square root of 6. Sometimes people will say 2 root 6. They don't even say times. So you might hear it referred to as 2 root 6, which means you're putting the square root sign there and you're putting the 6 under the square root sign. Let's try one more, and then we're going to talk about another method to do this same thing. So let's try 42. I'll do 48 instead. So the square root of 48, 48 would fall right under 49. I know 36 is not a factor, 25 is not a factor. What about 16? 16 times 3, I think, will give me 3 times 6 is 18. Yep, 48. So I'm going to put my perfect square first. 16 times the square root of 3. And I'm going to have 4 times the square root of 3 then. Or, as some people would say, 4 root 3. So this would be my answer, 4 root 3. Now, there is another strategy you might prefer rather than trying to think of the factors that make up the radicand, and that is to use factor trees. So let's see how that works out. Let's go back to the square root of 18, and in the square root of 18, what you do is you start using prime factorization, and we're going to start with the first prime number times 2 times 9. Whoops. And I like to circle my prime numbers. I know that 2 is not a factor of 9, so I'm going to go to 3. And I have 3 times 3. Now, when I use this process, what I'm looking for is pairs of the same number when I get all done with my prime factorization. I know I'm all done with my prime factorization because I'm done with my branching and I have circled all the numbers that are there. So here is a pair of 3's. So what I'm going to do is I'm going to take the number itself, which is 3, not the 2 3's, not what their product is, but just the number itself, and it is going to go outside of the radical. What is going to go inside of the radical is the numbers that do not have a pair. So this is going to be 3 root 2, or 3 times the square root of 2, because my other number has to be included. And when I look back up at the square root of 18 doing it the other way, I can see that I have 3 root 2. So that way checks. I get the same exact answer. But what you have to remember is that you are finding pairs of the prime numbers down here. Let's try it with 24. 24 square root of 24. If I do my factoring, I have 2 times 12. Circle the 2. 2 times 6. Circle the 2. 2 times 3. Circle the 2 and 3. Now, I'm going to be looking for pairs of the same number. So here I have a pair of 2's. So I'm going to have 2 there. And you'll notice right here, I do not have another 2 and another 3 to go with each of these singulars, 2 and 3. So what I'm going to do is I'm going to multiply these together, and those are going to go underneath the radical sign. 2 times 3 is 6. And when you look over here at the way we did it before, 24 is equal to 2 root 6. 24 is equal to 2 root 6. So it works both ways. We'll try it with the 18. Oh, I already did that. I factored it. Let's do one that is going to, let's do 48. 48 is going to show us just another little characteristic of doing it this way. 2 times 24. 24 is 2 times 12. Circle the 2. I've got 2 times 6. Circle the 2. And 2 times 3. Circle the 2 and 3, and I'm done. So here I have pairs of 2's, but I also have another pair of 2's. So this is going to be 2 times 2, because I'm just writing the single digit of the pair that I circled for that one, the single digit of the pair that I circled for that one, and then what I have left, there's nothing to multiply that by, so that goes under the radical sign. So now I'm going to say that this is equal to 4 root 3 because I'm going to do that multiplication. And that is what the square root of 48 is equal to in simplified form. When I do it the other way, and I look for my perfect squares, 48 shows up right here. So 36 is not one of the factors. 25 is not one of the factors. 16 is one of the factors. And so we did that right here, and we got 4 root 3. And down here, we have 4 root 3. So either method that you like will work. You just have to make sure that you're thinking through the steps and that you check when you're finished. 4 times 4 is 16. Is 16 times 3 48? That should help you minimize your errors.